Imagine if the moon just rotated in place. We would be able to see all sides of it, right? Of course, the Earth spins. But to keep things simple, let's assume it's stationary for now. Let's add a yellow line to highlight the moon's rotation. As the moon turns, the line shifts from vertical to horizontal. Back to vertical again. This shows it's rotating. But what if the moon didn't rotate at all, and it just orbited the Earth? Would we still see all sides of the moon? Now, what if the moon both rotated and revolved around Earth? In this case, we'd still have a full 360-degree view of the moon, no hidden sides. But what if the moon rotated at exactly the same rate it revolves around Earth? Look closely, and you'll see that only one side of the moon faces us, always. This is the situation we have today. One side of the moon, called the near side, always faces the Earth. The other side, the far side, was first photographed by a Soviet spacecraft in 1959. However, humans didn't see it directly until the Apollo 8 mission in 1968. So, why does this happen? Why does the moon rotate in sync with its orbit around Earth? The answer lies in gravity. As Earth's gravitational pull weakens with distance, it's stronger on the near side of the moon compared to the far side. This creates a difference in the gravitational forces acting on the moon. The moon's center of gravity shifts toward Earth because of this difference. The center of gravity is the point where Earth's gravity seems to act on the moon. If the moon rotated faster or slower, this center of gravity would shift, and Earth would apply a torque to realign the moon, keeping only one side facing us. This interaction between the moon and Earth's gravity prevents the moon from rotating any faster or slower. This gravitational effect also stretches the moon slightly into an oblong shape. This happens because Earth's gravity isn't uniform across the moon's surface. The same happens with Earth's oceans. As Earth rotates beneath the moon's gravitational influence, the oceans experience high and low tides twice a day. Due to the moon's gravitational pull, this tidal interaction between Earth and the moon causes friction on the ocean floor, which, combined with the torque from the moon, gradually slows down Earth's rotation. Over millions of years, this will lengthen the day. In fact, 1 billion years ago, a day was only 19 hours long. Eventually, Earth's day will slow to about 46 hours, and Earth will become tidally locked to the moon, just as the moon is now locked to Earth. When that happens, only one side of Earth will face the moon at all times. By then, the moon will be much farther away from Earth. Both bodies will be locked in a slow, synchronized orbit around each other. Earth will always show the same face to the moon, much like how the moon only shows us one face. People on the opposite side of Earth will never see the moon unless they travel to the part of Earth facing the moon, where real estate prices might be high. In 1 billion years, the Earth-Moon system will be completely locked in its dot dance, with the moon appearing in the same spot in our sky day and night. It's fascinating to think about this future dot, where Earth and the moon are in perfect alignment. Finally, consider these questions. Does the far side of the moon ever see the sun? Can you ever see Earth from the far side of the moon? And if you were standing on the moon and looked straight up, would the Earth ever stray from directly above you? These are great questions that invite further exploration into the science of our celestial neighbors.